So ngayon titignan natin yung isang application ng derivatives which would be related rates. So sa related rates, yung gusto natin gawin ay i-compute or hanapin yung change of one quantity in terms of the rate of change of another quantity na possibly mas madaling ma-measure compared dun sa isa. To illustrate, let's imagine na nagpapump tayo ng hangin sa isang balloon. So both the volume at yung radius nung balloon nag-i-increase. And syempre, yung rate ng pag-increase ng volume, related din siya dun sa rate ng pag-increase nung radius nung balloon natin, assuming spherical yung balloon. Now, between those two values, probably ang nakokontrol natin ay yung rate nung air na pumapasok. So, yung rate ng volume, yung nakokontrol natin. And using that information, tatry nating hanapin yung rate of change naman nung radius. Let's put some specific values dito sa situation na to. So kunyari, we have the scenario where the volume changes at the rate of 15 cubic meters per second. Kano kabilis mag-increase yung radius ng balloon pag yung diameter ng balloon ay 40 centimeters? So hindi naman constant yung rate ng pag-increase ng radius, 'di ba? Imagine sa simula, pag deflated yung balloon, sinimulan mo siyang i-inflate, mabilis yung paglaki nung radius kasi biglang lolobo yung balloon eh. But as your balloon gets bigger and bigger, hindi na ganun kabilis no yung pag-increase nung ano niya, nung radius niya. Although yung rate nung pag-increase ng volume nakadepende pa rin siya dun sa pinapump mong hangin sa kanya. So, pwedeng constant yung rate nung pag-increase ng volume, pero bumabagal yung pag-increase nung radius. Like, di ba, pag malaki na yung balloon, parang hindi mo nakikitang agad-agad lumalaki yung radius niya. Parang hindi na ganun kabilis yung paglaki. Compared sa simula, konting hangin pa lang, lalaki agad yung radius ng balloon natin. So to solve this problem, we'll follow itong suggestion from our textbook and from our LGs na flow. So it's like solving word problems sa grade 7. We'll start with defining the variables. So let V be equal to the volume of the balloon and R be equal to the radius of the balloon. Our second step is to identify the givens. So yung rate of change down ng volume, which would be dV over dt, is 15 cubic meters per second. Step 3, we'll identify yung values na hinahanap natin. So we are looking for dr over dt, which is the rate of increase nung radius. And specifically, hinahanap natin yung rate na to when r is equal to 20 centimeters. Bakit 20 centimeters? Yung given sa atin 40, diameter yung given. So radius is 20. Step 4, we need to write yung working equation natin. So how can we relate yung volume ng spherical balloon natin sa radius niya? E di we use the volume formula for the sphere where V is equal to 4/3 pi r cubed. So this is our equation. Step 5, we will differentiate both sides with respect to time. Kasi rate to no? Rate changing over time. So doing that, we'll get dV over dt. So dinifferentiate natin yung volume with respect to time. This is equal to 4 pi r squared. Kasi di ba r cube, bababa natin yung 3, magka-cancel dun sa 3 sa denominator, times dr over dt. So what we're doing here is we are applying implicit differentiation. Kasi we have two different variables, pero dinidifferentiate natin sila with respect to a third variable, which is time. Step 6, we will now substitute the values that we know and solve for what we're looking for. So dV over dt is 15 is equal to 4 pi r squared, but r is equal to 20 times dr over dt. So i-isolate natin si dr over dt kasi siya yung hinahanap natin. It will be equal to 15 over 4 pi times 400 or 3 over 320 pi centimeters per second. Final step, we will state our conclusion that the radius is increasing at a rate of 3 over 320 pi centimeters per second when the radius is equal to 20 centimeters. for our next problem, let's pause the video first. I mean, you should pause the video first at basahin yung problem bago natin sagutan. Okay, now that you've read the problem, let's follow yung steps na ginawa natin kanina para ma-solve yung hinahanap natin. Step 1, let's define our variables. So maganda, in this case, to draw yung scenario. We have our wall, our ground, and our ladder. Let's label the values. 12 feet yung ladder, y yung height nung nung setup, and x yung horizontal distance ng setup. So y is the vertical distance. Step 2, let us identify our givens. So sabi sa atin, the bottom of the ladder slips away at a rate of 1 foot per second. So dx over dt is equal to 1 foot per second. We are looking for the rate ng pagbagsak ng ladder vertically. So yung dy over dt when x equals 4, when the horizontal distance is 4. So lagay na rin natin dito, x equals 4. Step 3, identify yung hinahanap natin. Nabanggit ko na kanina. We're looking for dy over dt, which is the rate of the sliding down of the top of the ladder when x is equal to 4. Step 4, let's write our equation. Ano bang meron tayo? Meron tayong right triangle na setup. So we will use the Pythagorean theorem and write it na x squared plus y squared, yung sum ng legs, is equal to 12 squared, which is the square of the hypotenuse. Step 5 is to differentiate both sides with respect to time. So differentiating si x squared, that will be 2x times dx over dt. So again, implicit differentiation. Differentiating y squared, we'll get 2y times dy over dt. And the right-hand side of the equation is a constant. So pag dinifferentiate natin siya, we'll get 0. Step 6, we'll substitute the values that we know and solve for yung hinahanap natin na dy over dt. So meron tayong value for x, for dx over dt. Wala pa pala tayong value for y. Pero madali lang yun. I-solve natin siya. Kasi at x is equal to 4, y is equal to, again, apply natin yung Pythagorean theorem, the square root of the square of the hypotenuse minus the square of one of the legs. So 12 squared minus 4 squared. This is equal to the square root of 128, or 8 times the square root of 2. Substitute na natin, we'll get 2 times 4, yun yung x, times dx over dt, which is 1, plus 2 times y, 8 squared of 2, times dy over dt is equal to 0. Isolating si dy over dt, we'll get that this is equal to negative 8 over 16 square root of 2, which is equal to negative 1 over square root of 2, or negative square root of 2 over 2 feet per second. Bakit siya negative? Kasi bumabagsak yung rate, paliit ng paliit yung y. Right? Kasi nagsislide down yung ladder. Yung y natin, papunta siyang 0 habang bumabagsak yung ladder. So yung rate of increase niya ay negative. Kasi nagde-decrease siya. And we're ready for our conclusion. We could say that the top of the ladder is sliding down at the rate of negative square root of 2 over 2 feet per second. At x is equal to 4. Kasi nagbabago din yung rate ng pagbagsak habang gumagalaw yung ladder. So we should have mentioned that at x is equal to 4. Now let's use the same setup and look for another value. So pause the video, basahin yung problem, and then when you understand yung hinahanap, balik tayo. Okay, so ang hinahanap natin ay yung rate of change ng angle between the ladder and the ground. This time when the bottom of the ladder is 6 feet from the wall, so x equals 6. So let's follow our steps. Step 1, let's define our variables. So drawing natin yung setup natin. Again, we have the wall, the ground, the ladder in blue, it's 12 feet. Let's indicate the horizontal distance by x and the angle theta. X is the horizontal distance and theta is the angle between the ladder and the ground. Step 2, let's identify our givens. So same scenario sa taas, nagsislide yung bottom ng ladder at a rate of 1 foot per second. So dx over dt is equal to 1. But this time, yung hinahanap nating moment in time is when the horizontal distance is 6. So x equals 6 And that x equals 6, cosine theta is equal to adjacent over the hypotenuse, kaya 6 over 12, which will give us theta is equal to arc cosine of 1 half, which is pi over 3 radians. Step 3, let's identify yung hinahanap natin. We are looking for d of theta over dt when x equals 6. Step 4, let's write our equation. Cosine theta is equal to x over 12. Adjacent yung x over the hypotenuse, which does not change at 12. Step 5, let's differentiate both sides. So in terms of t, so dt of cosine theta should be equal to derivative in terms of t ni x over 12. So the left-hand side will give us negative sine theta times d theta over dt is equal to 1 over 12 times dx over dt. Next step is to substitute yung alam nating values at isolve yung hinahanap natin. So theta is pi over 3, so we'll get negative sine of pi over 3 times d theta over dt. This is equal to 1 over 12 times dx over dt, which is equal to 1. Solving for d theta over dt, we'll get 1 over 12 times negative 2 over square root of 3. Kasi diba, sine of pi over 3 is square root of 3 over 2. That's negative nun. It's reciprocal. This is equal to negative of 1 over 6 times the square root of 3. Rationalizing that, we'll get that it's equal to negative square root of 3 over 18 radians per second. Again, negative, kinukuha nating rate. Does that make sense? Well, as your ladder falls to the ground, yung angle natin, syempre magsasara, mag-a-approach ng 0. So it makes sense na yung rate of change niya ay negative. Let's state our conclusion na the angle is changing at a rate of negative square root of 3 over 8 radians per second when x is equal to 6 feet. So what can we conclude from our examples? No? Wala tayong isang working equation or working formula na i-differentiate. The equation will depend on the scenario. So as you look to your learning guides, as you look to your textbooks, syempre, pag nag-iba yung scenario, dapat it's on you to write down yung applicable na equation dun sa scenario na yon. If we have time, we could take a look at other scenarios so we could solve more related rates problems. But for now, hanggang dito muna tayo at salamat sa pakikinig.